So the previous session we have discussed about IPv4 address and net logics, right? So IPv4 is 32-bit address in the form of decimal. Like 32-bit address is divided into 4 portions. Technically, we call octet. Like each octet is being separated by dot, and we clearly discussed how to convert from binary to decimal and decimal to binary also. And later, IPv4 address ranges like 0.0.0.2, 255, 255, 255.255. Between we have 2 power 32 combinations, which is 4.3 billion IP addresses. All right. Is all 4.3 billion IP addresses is classified into 5 classes, like A, B, C, D, and E. ABC classes are reserved for what purpose?
LAN and WAN.
LAN and WAN. Yeah. Class E address are reserved for what purpose? Class E. R&D. Okay. Class D.
Multicasting.
Multicasting. Yeah. Okay. So based on that IPv4 address logics, I have a few quick questions. Let me ask you quickly. Yeah, here 128.1.2.9. This IPs belongs to which class?
Class B.
It's a class B,
Class B.
128, right? Yeah. So then what will be the network ID of this address?
1.0.0.
1.1.
Yeah. 128.1.0.0 is the network ID, and broadcast ID? 255.255, and then what will be the subnet mask of this IP address?
255.255.0.0.
Perfect. Now this address is private IP address or public IP address?
Private.
128.1.2.9
Public
is it
IP.
public or private? Yes, it's the public IP, right? Yeah. So these all the logics we already clearly discussed in IPv4 with the class E examples, class B examples, and class E. And even class A, number of networks and number of hosts, we know that. And class B, class A also. But main question is, in number of host calculations, in number of hosts, we do -2, right? Why -2 in number of hosts?
One is network ID, second thing is broadcast.
Very good. So one for network ID and broadcast ID. In number of networks, for class A, we are doing -2. Why here?
Global ID and loopback ID.
Global ID, one for global ID and loopback ID, which is 0.0.0 is a global ID, and 127.0.0.0 is what? Loopback ID, right? Yeah. So today, let me continue with IPv6. Before that, so I'm asking to everyone, do you have any doubts regarding the IPv4 addresses? So what we have discussed yesterday, do you have any doubts? Is it clear for everyone? Perfect. Right now, let me continue with IP address. Two versions we have, IPv4 and IPv6. IPv4 is 32 bits and IPv6 is what? 128 bit. IPv4 32-bit address is divided into octet format, right? Like one octet is
8 bits.
8 bits. Like total how many octets is divided?
4.
4 octet. 4 octets are 32 bits. Like IPv6, 128 bits are divided into quartet. In IPv4 we call octet. In IPv6 we call it as a quartet. Like one quartet is, yeah, before that I'll tell you one thing. See, in IPv4 is a format of what? Decimal language, right? So yesterday we seen how to convert from binary to decimal. So IPv4 is decimal format. IPv6 is hexadecimal format. So that is why IPv4 we called dotted decimal notation. IPv6 one quartet is equal to 4 hexadecimal numbers. Like entire 128 bit of IPv6 address is divided into 8 quartets. So IPv6 should be is what? 8. 8 quartet. So one quartet is 4 hexadecimal means 8 quartets. How many hexadecimal numbers? 32. 8 into 4. 32 hexadecimal digits. Like in IPv, for example, 4 octets, 192.168, 1.10, right? So first octet, second octet, third octet, fourth octet, each and every octet is being separated by using a dot. That is why we call it is dotted decimal notation. We use dot, right? IPv6, first quartet, second quartet, like each quartet is being separated by using colons. So we know very well about IPv4. Example, you can say 192.168.1.2. Then what about IPv6? So IPv6, it should be 128 bits, and the format is hexadecimal combination, like quartet formats. One quartet. You can read this. IPv6 is 128 bit address. It is represented as 32 hexadecimal numbers arranged in 8 quartets of 4 hexadecimal digit separated by colon. Example is this. In hexadecimals, like A, B, C, D, E, F are not case sensitive. We can use uppercase also, lowercase also, no issues. This is example of IPv6 address, guys. Okay.
Hello? Hello, Bolo?
Yeah. Has any doubts?
No.
Okay. Now let me continue here. So let me write some few
I
statements.
tried to get the same materials from Zoom application, but when I click on that, I'm not getting any books. I mean, any material.
So have you downloaded your Zoom Technologies application? I'll tell you. See here, 1 hexadecimal equal to 1 hexadecimal is equal to 4 bits. like 4 hexadecimal, which is equal to 16 bits or 1 quartet. Like 8 quartets is IPv6. So let's see the state number 1. First statement. 1 hexadecimal is 4 bits. So what are the hexadecimal numbers? Let me write first here. Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimal numbers. 10, it's A. 11, it's B. 12, it's C. 13, D. 14, E. 15, F. So 1 hexadecimal is 4 bits, right? Let me take a 2 power n values. Like 2 power n can be 2 power n can be 0, 2 power n can be 1, 2 power n can be 2, 2 power n can be 3. So what is the 2 power 0?
1.
Any power 0, 1. 2 power 1, 2, 2 power 2, 4, and 8. These are the values, right? Okay. Now how you can write 0 in binary in 4 bits? Like 0 indicates what? Your bit is off. 1 indicates on. So 0 indicates 0.00 zeros, right? Then how can write as a 1 in binary? 0, 0, 0, 1. How can write as a 2 in binary? 1, 0, 0, 0, 1, 0, right? What about 3? Like 2 plus 1 is 3, right?
0,
So
1,
0,
1,
0, 1, 1.
1.
4,
0, 1.
100.
0,
1 0 0
0, 1, 1, 0.
0 1 0 0.
yeah, exactly. 0, 1, 0, 0. What about 5? 4 plus 1 is 5, right?
0
1,
1
1, 0, 1.
0, 1, 0, 1.
0
Perfect. 6, 4 plus 2,
0 1
0, 1, 1, 0. 7,
0,
1 1 1
perfect. 8,
1 0 0
1, 0, 0, 0.
9,
1, 0, 0, 1. 1, 0, 0, 1.
1, 0, 0, 1. Now what about A? How can I add A in binary? Same. 8, 4, 2, 1. So A means what? It's a 10. So 8 plus 2 is 10, right? So 1, 0, 1, 0. B. How can it is B in binary?
1011.
1, 0, 1, 1. What about C? 1, 1, 0, 0. D.
1101.
1, 1, 0, 1. E. 1, 1, 1, 0. F. 1, 1, 1, 1. So that is the first statement here. 1 hexadecimal number is equal to 4 bits, right? Now second statement, 4 hexadecimal numbers, which is 1 quartet. Let me write example of IPv6 here. 4 hexadecimal, like 2001. Here 4 hexadecimal, so this is we call 1 quartet. Next quartet, so each and every quartet is being separated by using colon. So colon 0 space 0 0 something. I'm writing some numbers 2C colon. Let me make it a zeros, all zeros. So first field, I mean first quartet, second quartet, 3, 4, and fifth one, And sixth one, 7 and 8. Clear? So this is example of IPv6 address. This is a first field, first quartet, second, third, fourth, fifth, sixth, 7, 8. So these IPv6 address we need to be assigned for a computer, guys. But how computer can understand it IPv6 address and how we can understand this is. So to represent IPv6 address, we have some rules. So by using the rules, we can understand easily. Let me explain clearly. Rule number 1. So rule number 1 is from any field, from any quartet, leading zeros are omission. We can omission the leading zeros. And any leading zeros, we can omission it.
Balu, can I interrupt you here, Balu?
Yes, please.
Can you go back one time from after converting the binaries? How are we coming here for the IP address? Can you once again tell it?
IP address. This one.
Yes.
Yeah, just random numbers I took this. Simply, there is no logic y2 here, 0 here, 0 here. Just I'm taking the combination of some hexadecimal combinations.
It is a rough example that you're giving, is it?
Exactly.
Okay.
Yeah. So first understand the rules, then I'll explain that clearly. What is the rules here? It is rule number 1, from any field, from any quartet, leading zeros are omission. Take example of first field, first quartet, like 2001, we don't have any leading zeros, right? But in second field, in second quartet, 002C. So first two zeros are leading zeros. We can omission it. We can write as a 2C directly. Okay. So that is a rule number 1. So rule number 1 is from any quartet, leading zeros are omission. Rule number 2, from any field, 4 successive zeros substituted by 0. So 4 successful zeros. In third quartet, we have 4 are successive zeros, right? So 4 successive zeros are substituted with 0. So these are the basic 2 rules. So I repeat, rule number 1, leading zeros are omission. Rule number 2, 4 successful zeros, 4 successive zeros substituted with 0. Is it clear, everyone? Now, anyone can please tell me how we can represent this omission of zeros and substitute with a single zero? As this. Can we change anything in the first field? No. So as is. Let me write here. It is a 20001 colon. And second field, first 2 zeros are leading zeros. So you can omission it. Then you can simply write it as a 2C colon. And third field, 4 successive zeros
Zero.
substituted with a single zero colon. Again 4 successive zeros substituted with 0. Again 4 successive zeros colon. In sixth field, we have 3
Yes.
leading zeros, right? So
Yes.
leading zeros are omission. We can simply write is what? F colon. Again 4 successive zeros. 0 colon 0. So like this, we can represent IPv6 like this, guys. Is it clear for everyone, guys? Yes, please. It's clear?
Yes.
Good.
Yes.
Yeah. Now, rule number 3. So what is the rule number 3 means? Multiple fields of zeros. Multiple fields of zeros. It can be 3 fields, or it can be 2 fields, it can be 4 fields, it can be 5 fields. Like multiple fields of zeros represented with double colon. So double colon indicates multiple fields of zeros. Okay. So it can be 3 zeros also. Don't think so 3 zeros, then you have to use 3 colons. 4 zeros, 4 colons is not like that, guys. It's wrong. It can be 3 fields, or it can be 4 fields, or 5 fields. Simply we can represent what? Double colon. So in IPv6, double colon means what? Multiple fields of zeros. It's clear? Now finally, how we can represent this IPv6 again now? 2001 colon 2C, okay,
double colon,
double colon. Yeah, because of multiple fields, we are replacing
multiple,
with the
yeah,
double colon. Yeah.
yeah,
Then F
double colon,
double colon. Right. So now, Madhu, so listen here. This IPv6 address we have assigned to a computer. Now,
yeah,
how my machine can understand, okay, this is IPv6 address. Actually, IPv6 address, how many fields will be there? I mean, how many quarters will be there?
8.
8,
8. But how many we have assigned here? 1,
1,
2, 3. 3
3,
fields we have assigned, right? Then how
yeah,
many are missing?
5,
Where is 5 fields now? In this address, where is 5 fields exactly?
but we assigned multiple colons, right? It's multiple areas is there. That's what we assigned multiple colons.
Okay.
Instead of that areas,
Yeah, but the point is here, your machine will get confused because of there are 5 fields are missing. So where is
yeah,
5 fields? The 5 fields are in after 2C or after F. So your device will understand maybe here 2 fields and here 3 fields, or maybe here 3 or maybe here 2 or maybe here 5. Like, so the machine don't know exactly where is 5 fields of zeros, right?
yeah,
So by seeing the diagram, we can understand that as a user, we can okay, but how your machines can understand is not possible. So this is invalid IPv6 address. It's invalid. Then how we can
after double
represent?
colon, we have to write it down 0.
Exactly. See, so the rules here, what is the rule says? Omission of zeros, leading 0 in any quartet can be omitted. That is rule number 1. 4 successive zeros in a quartet can be substituted by 1 0.
1, 0.
Rule number 3 is, listen carefully here, multiple quartet with 0 can be represented as double colon, but only once in a address. So double colon only one time you have to use. So here we have used it 2 times, here and here, right? Then your device will be confused.
Yeah,
So we have to represent either in this place or in this area. Any one area only have to be represent this actually. So that is why if you use the multiple times, then it is a invalid IPv6 address. So finally tell me, so what will be the valid IPv6 address? 2001 colon
colon, 2C colon, double
2C
colon, double
double
colon,
colon
F colon,
F colon
0,
0 colon
0.
0. Perfect, very good. So this IPv6 address I have assigned to a device. Now, how my PC will understand exactly here is 1, 2, 3, 4, 5 fields, 5 quarters we have been assigned, right? Then how many are missing?
3.
3. Then your PC will understand automatically wherever double colon is there, will understand 3 colons. Okay?
Yeah.
So this is IPv6 valid IPv6 address. Clear? So these are the basic 3 rules we can understand easily. Omission of zeros and successive zeros and multiple fields of zeros with the double colon representation. Is it clear for everyone?
Third rule once again.
So rule number 3 is multiple fields of zeros. See here we have 1, 2, 3. 3 fields is there, right? The 3 fields we can represent with double colon. Not only 3 fields, it can be 4 fields also or 5 fields also. Like, I will do one thing. in F place, if I use 0, then it is also become 0, right?
Yes.
Now we have continuous fields of zeros.
Yeah.
These all zeros we can replace simply with what?
Colon.
Double colon.
Yeah, double colon.
This simply can write is now 2001 colon 2C double colon. That's it. Why? Because remaining all are what? Zeros. So if we assign like this, now how your PC can understand? We just assign only two fields, right? 2001 and 2C. How many are missing? Actually, IPv6 is 8 fields. How many are missing here? 6. Then wherever double colon is there, then your machine will understand automatically there are 6 fields of zeros. Okay?
Okay.
Yeah. So we'll see a few more examples.
Balu,
Yes, please.
instead of giving for 3 zeros, the double colon, we give it to 2 zeros and just leave the 3. Is it still valid?
No. I mean,
So
3 zeros you're writing as is, right?
Yeah.
And remaining 3 are using double colon.
Yeah.
Then your IPv6, then how we can completely customized. Yes, of
Okay.
course we can write like this also, like
Mhm.
2001 2C colon 0 colon 0 colon 0 double colon. Yes, of course you can write like this also. But why we are living like this? We can represent simply simplification. IPv6 simplification you're doing now here.
Okay.
Yeah.
Thank you.
So here we have few examples. So everyone you try to solve it. First one. Yes, please.
Zero zero one colon 0DP8 colon
2001 colon.
colon
DB8.
0DP8
Why you can write 0? 0 you can omission it, leading 0.
DB8.
Yeah,
Okay, DB8
DB8
colon 1
1.
colon 3 leading 0, so you can omission it, you can write as a 1, okay, colon
1000
1000, okay.
Double
and
colon. Double colon.
Double colon.
Multiple fields of zeros, we can represent with double colon, perfect, okay.
EF0.
EF0
Yeah, leading 0 you can omission, you can write it as a EF0,
BC.
BC00.
BC00. Very good, guys.
BC.
Exactly. So like we can represent it.
My question, Balu.
Yes, please.
In IPv4, we have network and the host part. We want this. The entire concept is different, or it will be again the same.
Yeah, actually here in IPv4 we have the classes, class A, class B, class C. In class A, first octet network portion and network and host portion, right? But in IPv6 we don't have any classes. No class A, no class B, no classes in IPv6.
Okay.
But how we can understand that network portion, host portion, I'll tell you that actually.
Okay. And
Yeah.
migrating from IPv4 to v6 is possible, or again that
It's
numbering
possible.
should be
There are different type of technologies there, like how to work together with IPv4 and IPv6. So that comes in an advanced concepts actually, you know, in CCNP level. Yes, it's possible. Like because of we are working nowadays with IPv4. So for next generation, we are moving to IPv6, right? Yes, we can migrate to IPv6. So over the night we cannot do, right? So existing IPv4 slowly, like one branch to another branch, one area. So we need to migrate to IPv6 slowly. So there is no
Thank you.
fixed date and fixed time to migrate IPv4 to IPv6. So we are moving on. All companies started actually. Yeah. Right. Second example, please. How we can represent the second one?
2002.
000 colon
2002 colon
1111
1111
colon
CF.
4CF
colon 4CF.
Double colon is
The colon
Double colon.
Here,
Double-
4 fields of zeros we can represent with double colon
2F.
2F.
2F, because again here 2 leading zeros is here. So this IPv6 address, if we assign to your computer, now how your machine can understand 1, 2, 3, 4 fields we have assigned. We assigned 4 fields, right? That how many are missing in it? 4 are missing.
4.
So where you have used double colon, then your machine will automatically understand that wherever double colon is there 4 fields of zeros is here. Clear? Yeah. Next example, please.
3F.
3FF.
3FFF, okay.
Double colon.
Double
5D.
colon. 5D.
Double colon
5D.
5D
0
colon
Zero.
0
colon 9CE.
9C.
in CE. Very good, guys. Appreciate you to everyone. Next example, please.
2001.
001.
2001
Double colon.
double colon
Space.
FACE
FACE
Colon.
0C.
colon
B00C.
B00C.
Double colon.
Double colon.
Only one, sir. Only
Come
one.
on. How we
Only
can
one.
make it is again double colon? We already used
Only
double
one.
colon,
0.
right here.
0, 0.
So remember rule number 3. Represent of multiple fields of double colon, it only once in a address. So we already have used, right? So we cannot use again.
0069.
Colon 0 colon 0
69.
69. Right, very good. Perfect. Next example, please.
Hello, here on doubt here.
Yeah,
Second
please.
is, can the same IP address, can I write it as a 2001 00 FACE B00C double colon 69?
Exactly. Of course, we can write anywhere you can represent this. Only once in address. Either in left side also, then right side also, you can replace it actually. No problem. Okay.
Okay, thank you.
Yeah. Next example, please.
20 dB.
20 dB.
0.
Yeah.
Colon
0.
0 colon 0
Colon 0
colon 0
colon 0.
colon 666
Yeah. Colon 6666.
Double colon.
double colon
Double colon
5228.
5228. All right. Can I write like this IPv6 address 20 dB double colon 6666 colon 0 colon 0 colon 0 colon 5228? Can you write like this?
Yeah, sir, but increasing of zeros we can see, sir.
So which is a valid one? First one is a valid or second one is a valid? Which is valid?
Both is valid, sir.
Perfect. Both are valid.
This is what you tell us, which is the procedure that the industry follows.
Yeah, that is. See, anywhere you can replace, but the logic is here. Instead of replacing of 2 fields, better to replacing of 3 fields, right?
Yeah, sir.
That is only logic. There is no like a proper pattern like industry will follow this pattern only. So anyone you can use it, both are valid. But the thing is, simplification of IPv6 address is important here.
Okay.
Yeah,
Instead
sir.
of replacing of 2 fields, better to go to 3 fields, right? That's the best thing. So first one is, second one is, both are valid. First one is recommended. It's clear?
Yeah, sir.
Yeah. And finally, last one, please. Last example.
2001
2001
colon
colon
1111
1111
double colon
double colon
1.
So 128 bit of IPv6 address, finally we have represented it very simply by using the basic 3 rules, right?
Yes.
So this is entire 128 bit of IPv6 address, guys. So which is simple, IPv4 or IPv6?
IPv6, sir.
Okay. So if you understand the logics, both are same, right?
Yes, sir.
Good. Any more doubts, guys?
No, no.
IPv6? Yeah, I have a doubt. Can I ask you?
Yes, sir.
So here are two computers, host A and host B. Host A can I use 192.168.1.0 IP address? Can we use it? Can I assign it? No. Why?
But it's an IPv4 address.
Yeah, whatever. I'm asking about IPv4 only.
Yes.
So can I assign this IP address to computer?
No. It's a network IP.
No, it's a network ID. We cannot use it, right? Yeah.
Yeah.
So can I use 192.168.1.10? Yes. Okay. Now neighbor computer 192.168. If I assign 1.10, will they communicate?
No.
No. IP address conflict. If I use 2.10, will they communicate?
No, different networks.
No. Different network. Yeah. If I assign now 1.20, will they communicate?
Yeah.
Yeah.
So actually, this is not my question. My question is, so host A 201A colon 2CF double colon 29 for host A. For host B 201A colon 2CD 2CD double colon 29. Now in IPv4, okay, in IPv6, will they communicate host A and host B? Yes or no, or we don't know? What is the answer?
We don't know.
We don't know his
Actually, we
answer.
don't know, but as per he said that there is no classifications, and if it is there, then it should.
Okay. So actually in IPv4 we can easily understand because of in IPv4 we clearly discuss there is a classes and network portion, host portion, then we can compare it and we can understand. But what about in IPv6? In IPv6 we don't have any classes, right?
Correct.
So how we can come to know both are in the same network? Will they communicate or not, or will they don't communicate means? So first let me write this IPv6 address in 8-quartet format. 201A colon 2CF colon 0 colon 0 colon 0 colon 0 colon 0 colon 29. This IPv6 address, let me write it. 201A colon 2CD colon 0 colon 0 colon 0 colon 0 colon 0 colon 29. So IPv6 is how many bit address? 128, right? Like out of 128, first 64 bits and second 64 bits. So first 64 bits represent network portion, second 64 bits represent host portion. Okay, no classes. Like any IPv6 address, first 64 bits are network portion, that's it. So first 64 bits means how many fields? I mean, how many quartets?
4.
First to 4 quartet. First one, second one, third one. So these indicates network portion. Here also, first to 4 fields indicates what? Network portion. First field 201A, host B also 201A. Second field 2CF. Second field is what here? 2CD. It is a 2CF, it is a 2CD. Now both are in same network portion or different network portions?
Different network portions.
Different network portion. Will they communicate?
No.
No. So this is how we can understand the logics. In IPv6 also, the machines can communicate. I mean, machines are in same network IPv6 or different network IPv6. Okay. So you just focus on first 64 bits, which is first 4 fields. In IPv4, we can clearly tell this both can be communicated. How we can say? Because of is a class C. In class C, network host, right? So as a user, we can understand this n hash, but how your machine can understand where is network portion, where is host portion based upon what?
Subnet.
Subnet mask. So what will be the subnet mask of this IP addresses here? 255.255.255.0. So by assigning a subnet mask, then your machine can understand which octet is a network portion, which octet is a host portion. In IPv6, what is the network portion?
First 4 octets.
As a user that we know, but how your machine can come to know it? In IPv4, in class A, how many octets?
Sorry, Balu, can you repeat it?
In IPv4, by using a subnet mask, machine can understand where is network portion and host portion, right?
Correct.
In IPv6,
First 64.
first 64 that we know, but how your machine can understand means that indicates a /64. Okay. So in IPv4, we call it is a subnet mask. In IPv6, we call it is subnet prefix length. Subnet prefix length. So what is the length of the prefix is 64 bits, means /64 we can represent it. I'll show you that how can assign IPv6 address for your devices. The same pattern, how we are assigning IPv4, the same like right click on your Ethernet adapters, properties. So generally for IPv4, we click on IPv4, right? For IPv6, you just click on IPv6, properties. Yeah, so here we can assign like 2001:2CF :29. And the next line, you can see here, next line is what? Subnet prefix length. What is the subnet prefix length here?
64.
64.
Yeah. If you press tab, automatically get 64, we can get. Then you press OK. IPv6 assigned.
64 is a default then. There is no need to change the Balu or
Default.
can
There is a
change.
default. If you want to customize, we can do that actually. Default is 64.
Okay, customization means it will comes under the
Like
subnetting.
if we say here /32. Here I have assigned /32. Now this host B can understand first 32 bits are network portion. Default is 64. You want to customize, you can do that actually.
One more topic here, Balu. So we are covering this subnetting also in this course.
Yes, of course, we need to understand IPv4.
Okay.
Yeah.
Yeah.
Without subnetting, how we can work with your networks now? Yes. Is it clear, guys? Any doubts about regarding IPv4 and IPv6 both?
Small dot, sir.
Yes, please.
In IPv4, the IP address start with 0.0. In same way, in IPv6, there is any order starting with 2001 or like that.
Yes, exactly. There is some ranges is there in IPv6. Again, IPv6 also we
Balu, we lost your voice.
yeah. Hello. Yes, in IPv6 also we have IANA. Generally, IANA will provide, right? IPv6 IP addresses. So IANA will start from 2001. Yeah, for private IP addresses, public IP addresses like that. Okay. Any more doubts? In IPv4, what are the special IPv4 addresses we have?
0.0.0.0 and 1.7.0.0.
Private IP address is there, right? And public IP address will be there. Global ID we have.
Loopback.
Loopback ID we have, yes.
Broadcasting ID.
For
Network ID.
IPv6 always start with 2001.
Yeah, that is the name I'm explaining now. Global ID, loopback ID, and it's private IP, public IP, global ID, loopback ID, and multicast addresses. Multicast address and APIPA IP address also, like automatic private IP address. In DHCP concept, you can come to know about this. So these all are special IPv4 addresses. In IPv6, what about IPv6? Yes, in IPv6 also we have the private IP address, public IP address, global ID, loopback ID, multicast, and APIPA. But the names are different. So we know the range of private IP address, right? For class A, class B, class C. So other than private IP address are remaining all public IP address. Global ID is what? 000. Loopback ID is 127. Multicast is 224. Like we have certain ranges there, right? So in IPv6 also we have, say this, special IPv6 address and IPv4. And IPv4, private IP, public IP, APIPA, multicast, loopback, and default. In IPv6, private IPs are similar to, we call it is unique local. So any IPv6 starting with FC, that is private IP address, FC. That's fixed. If any IP address starting with 200, I mean 200 means what? ID, network ID. 2001 is IP address. So any IPv6 starting with the 200, that is global unicast, which is similar to public IP addresses. So FE80 link local, FF00 multicast, 00s default. These all are special IPv6 addresses. So we need to remember these things actually, FC, 2, FE, FF.
Can you keep this slide for a second, please?
Yeah, sure.
Bolo, the material, the same slides will get, or we'll get a different?
Yeah, same slides will be there in Zoom app.
We are not seeing these. You'll have to help us after the session, maybe.
No, you just download the Zoom technology application in Play Store. There
We
will
have to
be,
register first.
yes, we need to be registered.
There is
Then
also
you can
web also is there, no, sir?
Yeah, of
And
course.
not only application can be on web also.
Web also is there, yes.
Can you download?
No,
Can
sir.
you download?
No download. Only view option. Only browsing. Okay.
Sorry.
Yeah, please. Any doubts about IPv4 and IPv6?